Hello, my name is Gary Woods. I'm Vice President of Engineering for Norfolk Southern Corporation. At NS, we constantly strive to improve safety and the work environment through changes in the methods and equipment that are being used to accomplish our daily tasks. Ballast unloading has always been an area we have actively attempted to improve. The video you are about to see is a brief overview of the new Herzog PLUS train. PLUS stands for Programmable Linear Unloading System. NS has acquired train number 4, which is the latest and most current model of the PLUS system. The train has many features that will be briefly reviewed to allow a better understanding of what can be accomplished. Pay particular attention to the part concerning the pre-survey. The critical areas on the survey are the points of no dump zones, road crossings, switches, bridges, hotbox detectors, and other obstacles along the right-of-way. If the survey is accurate, you will achieve a precise unloading of ballast that is cost-effective.
In our endeavor to achieve our vision, Norfolk Southern has leased the new Herzog PLUS ballast unloading train. PLUS stands for Programmable Linear Unloading System. The train uses the Satellite Global Positioning System, or GPS, to precisely unload ballast. In this video, we'll discuss the following: what is GPS, an overview of the train system, PLUS safety features, an overview of the survey procedure, how to perform an unloading survey, and how PLUS precisely distributes ballast. Originally developed for the military, the Global Positioning System, or GPS, allows everyone to use satellites to determine where in the world they are. Many automobile manufacturers have incorporated GPS devices in their vehicles to assist motorists in locating gas stations or other areas. GPS is made up of 24 satellites that are placed in fixed positions around the Earth. Through the use of a device on Earth that receives these signals, we are able to determine our exact latitude, longitude, and altitude, or elevation. Herzog PLUS trains are designed to unload ballast via remote control. The system uses a computer to control the dump doors. The computer is programmed via a floppy disk that holds the information from the unloading survey. The survey is performed prior to the dumping of ballast and is very important to the accuracy of the unloading procedure. The computer-controlled dump doors can be opened and closed within a fraction of a second at speeds of up to 20 miles per hour. The system can be programmed to dump from 0 to 500 tons per side. Additionally, it can also be programmed not to unload in areas such as crossings, switches, hotbox detectors, and other obstacles that do not require ballast. The GPS also allows the train to operate at night. Night operation allows us to unload ballast as soon as the train arrives on location. This makes our ballast unloading operations more efficient and cost-effective. The GPS, used in conjunction with computer-controlled doors, has also created a safer operation. Because the doors are remotely controlled, ground personnel no longer have to walk along the side of the train. This can eliminate personnel injuries associated with ballast unloading, as well as exposure to ballast dust. The unloading survey is the most important procedure in this operation. This survey is performed prior to the ballast unloading and uses a high-rail vehicle, a computer, and an antenna. GPS uses 2 groups of satellites, the main group and correction satellites. These satellites allow us to place ballast to within 3 feet of a no-dump zone. It is important to note that there are certain areas that can cause satellite outages. Areas with heavy overgrowth, tunnels, areas that are next to elevators, or in the mountains and cuts, all can cause a momentary loss of signal. If this happens during your survey, you can manually log in dump points. In these instances, we have added in safety buckets to the program. During the survey, you will also program the tonnage of ballast to be deployed. You can program up to 500 tons per side, or program the system to dump on one side but not the other. You can also program the train to feather unloads as it approaches a no-dump zone. We'll discuss this procedure in more detail in the next segment. As you can see, The Herzog PLUS system is very flexible. Once the survey is complete, the information is saved on a floppy disk. This disk is used to upload the survey to the PLUS computer. The survey is the most critical step in using the Herzog PLUS system. Let's take a look at an example of how the survey should progress. When you arrive at the site, place the antenna on top of the high rail vehicle. Once on the rail, you must program a reference point. This reference point should be at a milepost at least 1 mile from where you need to begin unloading. The reference point allows the system to coordinate the longitude, latitude, and elevation points that will be collected during the survey. The first mile should be marked as a no spread zone. After 1 mile of no spread, begin logging your spreading requirements, no dumps, rate changes, and tonnage. In this example, we'll need to dump 300 tons per mile. To do this, you would program 150 tons per side. If you need to change it to 400 tons per mile, program 200 tons per side. The system will also allow you to feather rock up to a no-dump area. Using our example to feather ballast to a no-dump area, you would program the system to unload from 400 ton per mile to 300, 200, 100, and finally no dump. Once on the other side of the crossing, program the system to feather rock back up to the 400 tons per mile rate. When you are in GPS mode, you can program the unloading to within 3 feet of a no-dump area. If you're in an area where there is a GPS outage, you'll receive an alert message on the computer screen. When an outage occurs, you'll have to enter the points manually. While entering the points manually, it is important to remember that all the information must be precisely entered. While this still allows us to precisely unload ballast, it is not as accurate as when you are in GPS mode. Because of this lack of precision, the system employs a safety bucket feature. This feature allows us to unload ballast more than 3 feet from a no-dump area. For example, we may decide to cease unloading ballast 20 feet from a crossing or other fixed object. By using the safety bucket, we are assured that the ballast will not be unloaded on a crossing or any other fixed object during a GPS outage. As soon as the GPS signal is restored, the system will automatically switch back to GPS mode. If your survey is interrupted because of train traffic, you can stop the survey, clear the track. Then once the traffic has passed, return to the point where you stopped and continue the survey. At the end of the survey, you'll program a 1 mile no spread. Once the survey is complete, save your data to a disk. Remember, only 50 miles of survey should be saved to a single floppy disk. If you need to save more than 50 miles, you should save it to another disk. Mark each disk with the beginning and ending milepost, the territory, the date, and your name. 2 copies of the disk should be made, one for yourself and one for the NS official who is responsible for the territory. When the train arrives at the unloading site, the operator loads the survey from the disk into the Herzog PLUS ballast train. The computer status screen provides the operator with all the information he needs to perform a successful application. This status screen shows the operator the number of cars in the train, the length of the survey, the required amount of ballast for the survey, the left side and right side tonnage release, and the application rate, target rate, actual velocity, and target velocity. In addition to monitoring the amount of ballast being unloaded, the operator can also monitor each car's voltage and pressure. By highlighting the car, he can turn it off or on at any time. The target rate and target velocity are the values that need to be achieved to apply the proper amount of ballast. The application rate and the actual velocity rate show how much ballast is being applied and at what speed. During application, the operator monitors the target and application rates. If the application and velocity rates are above or below the targets, the operator radios the engineer and tells him to slow down or speed up until the application and targets match. The system is equipped with an off-track alarm. If the engineer has to take the train into a siding or crosses track and does not warn the operator, the off-track alarm will sound and the operator will shut down the program. The program can also be stopped if the train has to clear the track for train traffic. Once the ballast train is back on the track, the operator will activate Backup and Resume. Backup and Resume assures that the train is in the proper location to resume unloading. To prevent skip in ballast unloading, the system also fills in areas that may have been missed. If the train speed should fall to 5 miles per hour or below, the computer will automatically shut off and close the doors. Once the train speed exceeds 5 miles per hour, the operator presses the Resume key and the ballast application begins again. During unloading, the train speed is very critical to maintain a precise, uniform flow. At speeds below 5 miles per hour, the doors will close and the train will have to back up and fill in the areas that were missed. If the train exceeds 20 miles per hour, then the ballast is thrown too far out for the ballast regulators to reach. This is why it is very important for the operator to monitor the target and application rates and to keep in contact with the engineer. In addition to speed, the engineer must also maintain slack action. A long train could have as much as 30 feet of slack in or out. This means that cars furthest away from a fixed object, such as a crossing, could be as much as 30 feet away or 30 feet closer to the crossing. By maintaining a consistent speed and controlling slack, we can be assured that the proper amount of ballast is deployed. With proper assessment of track conditions, performing an accurate survey, and fully understanding the Herzog PLUS train's capabilities, you will be able to effectively unload the correct amount of ballast in the shortest amount of time.
As I stated earlier, the pre-survey is critical to the operation. As these trains come onto your territory, keep the points discussed in mind. With the PLUS train, you have the ability to load the correct amount of ballast at any location. The best features of this train are the ability to precisely unload ballast at an accelerated rate of speed without ground personnel on any track at any time. This is just another tool that will ensure that Norfolk Southern remains the thoroughbred of the transportation industry.
The Herzog PLUS train is just another example of how through invention and innovation, we will become the safest, most customer-focused, and successful transportation company in the world.